All right, today we're talking about direct variation. Direct variation, when we use the term direct variation always will come in the formula that I listed, y equals kx. And I'll explain what this formula is all about. We can find the answer to one variable by multiplying it by a constant, something that does not change. Okay, sometimes this is called the constant of proportionality. But this is what direct variation has to talk about. The K stands for constant. I know you think, why doesn't it start with a C? But in Germany, where this formula originated, constant starts with a K. So we use a K. All right, the K represents an unchanging number. The X represents an independent variable, and the Y represents a dependent variable. The Y is always dependent on whatever the constant in X is. All right? We use direct variations in several different kinds of word problems that we do. For example, if we wanted to figure out someone's total pay, we could use that formula to figure that out. Total pay is Y equals, say, $12 an hour times number of hours worked. So total pay is the constant is $12 an hour, or whatever you make, times the number of hours you work. Okay? Your total pay is fully dependent on how many hours you work. You always know what the constant is. So that's one example of direct variation. Another example of direct variation is miles traveled. So distance. We can figure that out quite easily. Our constant is your miles per hour times how long you went, times hours. We can figure out distance that way as well. So that is direct variation. There's some characteristics of direct variation, and we can even graph out direct variation as well. But there are some things that we need to know. The characteristics is if one variable is zero, the other is zero. In this case, it graphs a line through the origin. Graphs a line through the origin. And the second characteristic is if one variable changes, the other changes in a constant way. And again, it graphs a line, because we are able to graph direct variations quite easily. Okay? So far, so good. I'll pause it right here for a second. All right, so we were talking about direct variation, and I'm going to give you a few examples, and we're going to actually graph those out. So those few examples are going to help us indicate if something is a constant change or not. So let's start with 3 examples of direct variation. I'm using white for a reason right now. All right, so what if you take a taxi and it charges you $3 just to sit in it, then $2 per mile that you go? That's actually really cheap. Your formula for direct variation would look like this. When you want to know distance, equals, well, it doesn't even matter what variable you come up with, equals 2m plus 3. Because however far you go, just sitting down in the taxi costs you $3. After that, you're going to charge $2 for every mile that you go. All right? We could graph that out. But first we would have to turn that into a chart. All right? So let's turn that into a chart. If you go 1 mile, how much money is it going to cost you?
It's going to cost you $5.
If you go 2 miles, how much is it going to cost you?
10.
No, it's going to cost you 2 miles. That would cost you $7.
7. 2 times 2 plus 3. You go 3 miles, what's that going to cost you?
That's
$9, right? If you go, let's do one more. If you go 4 miles, what's it going to cost you? 11. Okay, so that is direct variation, or it isn't. All right, so to find out if we have direct variation, we should be able to have equivalent fractions. So 5 to 1, that should be a 7. I don't know why I wrote that. 7 to 2, 9 to 3, 11 to 4. Are all those fractions the same if we reduce them? And you can't reduce them, like a lot of those.
no.
Are they all the same?
No.
Therefore, that is not direct variation, because we can't set up an equal proportion, can we? Because all those fractions do not reduce down to be the same thing. What about the area of a square? Is the area of a square proportional to its side?
Yeah.
The formula for area of a square is A equals S2. Is this direct variation? Well, let's find out. Let's make another little chart. If the side is 1, what is the area?
1.
Yeah. If the side is 2, what is the area?
4.
If the side is 3, what is the area?
12. No.
3 times 3.
9.
If the side is 4, what is the area?
16.
16. Okay? Then, let's break it down. So the first one makes a fraction 1 to 1. Second one does 4 to 2. The third one does 9 to 3. And the last one, didn't give myself a lot of room, is 16 to 4. Do those all reduce down to equal amounts?
Yep.
Yes.
1 to 1 comes down to 1, 4 to 2 comes down to 2, 9 to 3 comes down to 3, 16 to 4 comes down to 4. Are those all equal?
Yep.
Are you
No.
kidding me?
No.
1, 2, 3, 4, not equal at all. That is not direct variation then. We can't reduce those down to an equal number. Now, what about perimeter of a square? The perimeter of a square is 4 times the length of its side. So that's P equals 4S. New formula. So, if the side is 1, what is the perimeter of a square?
It's going to be 4.
If the side is 2, what is the perimeter square?
8.
If the side is 3, what is the perimeter square?
12.
If the side is 4, what's the perimeter square?
16.
Okay, now let's see if this one is direct variation. We can find that out. 4 to 1, 8 to 2, 12 to 3, 16 to 4. If I reduce all these, what do I get each time?
4.
I get 4. Therefore, this one is direct variation because they're all proportional. I could reduce these down to the exact same number. I could not do that on this one with the area of the square, and I could not do that with the taxi one. It does not all reduce down. Did you get that? Okay. We cannot reduce those down. A further example is if I chose to graph those things. If I chose to graph them, I would also find that out. So I'm going to use colors to show each and every one of these. So we'll start off with this one right here. Oops, did I change the color? I didn't. We'll start off with this one right here. I'll use red to indicate this one. Sitting down the taxi costs you $3, right? That's 0, 3. Look at your other numbers. 1, 5. 2, 7. 3, 9. 4, 11. It makes a nice straight line, doesn't it? That makes a nice straight line. But it does not cross 0. Therefore, it's not direct variation because it has to go through 0. This one does not go through 0, even though it's a straight line. Okay? Look what happens with the square. Let's pick a different color. Maybe. Try to pick a different color. Okay? I'll use blue for this one. Let's pick it. So, we'll start out at 1, 1. I could have 0, 0 on this one. I could have that it's 2, 4. And then 3, 9. And then 4, 16, right at the very top of mine. Did I just lose that? Yeah, I did. Fix that. Let me go one over from there. Okay, now look at this line. See how it curves? See how that line curves? That is an indication that's not direct variation because it doesn't make a straight line. Okay, the red line makes a straight line but does not pass through 0. That's not direct variation. The blue line has a curve to it. That is not direct variation. Now the last one we'll do in purple. And you'll see, I could always start, if the side is 0, then we know the perimeter is 0. So I can start at 0, 0. Then it's 1, 4. Oops, I went to 2, didn't I? Finish that. Oh, this won't worry about that. 1, 4. And then 2, 8. And then 3, all the way up to 12. And then 4, all the way up to 16. Now that, if I use the ruler, I can make it straighter. It makes a straight line. I didn't use the ruler, so it makes it harder. That makes a straight line. Therefore, I have direct variation. Okay, so that's an indication. If you could graph something, you could come up with your direct variation. Your graph of direct variation always goes through 0, 0 and is a straight line. So turn to page 467, please, and look at those practice problems. Letter A, Sarah, would you read that, please? Weird name, by the way. You can pick a different name if you want. Not your name, the name in A. Read it out.
Trinity drew some equilateral triangles and measured their side lengths and perimeters. She decided that the perimeter of an equilateral triangle varies directly with its side length. Writing an equation for the relationship and identify the constant of proportionality.
Okay, let's write the equation. So let's start the equation. P equals, per perimeter, equals, what do we find out? Looking at that chart, what do you find out? The P is always how much bigger than the side?
Times 3.
It's always times 3. So that's P equals 3S. That's the formula. What is the constant of proportionality? Which number cannot change in this formula? It's the only number I wrote down. 3. So the constant is the 3 because it doesn't change. That's for A. Take a look at B. Cool? Read B.
The relationship between Sergio's age and Fernando's age is illustrated in the graph. And are their ages proportional? Is the relationship an example of direct variation? Why or why not?
All right. So look at the graph in your book on letter B. Is that proportional? Or is that direct variation?
No,
Why?
because it doesn't pass through 0.
Does not pass through 0. Okay? If it passed through 0, then we could say that Sergio's age would be a constant multiple of Fernando's, but it's not. All right, so Sergio is not, his age is not proportional to Fernando's age. So we could say that as well. Letter C. Nathan, read that.
The weight of water in a trough is directly proportional to the quantity of water in the trough. If 20 gallons of water weigh 166 pounds, what is the weight of 30 gallons of water? Find the constant of proportionality in pounds per gallon. Then writes an equation for the relationship using P for pounds and G for gallons.
Okay.
Start the equation P.
Okay, so we're going to start with the equation P equals. Okay. What is the other variable that we need to know? So first off, we need to find out the constant. Okay? And we need to figure out gallons. So we need to figure out what that constant is, the K. Okay? That's what we need to figure out first. We can do that with the first part of the problem. Nathan just read, if 20 gallons of water weigh 166 pounds, we can find the constant. We need to find out how much 1 gallon weighs. Okay? We can find how much 1 gallon weighs simply. 166 divided by, should have used white, divided by 20. How many times does 20 go into 166? How many times does 20 go into 2 go into 16?
8.
8. So 20 goes in 166 8 times. That's 160. I have a 6 left over, right? That means if I add a decimal, add a 0. Bring the 0 down. How many times does 20 go to 60? 3. Now I found my constant, 8.3. Each gallon weighs 8.3 pounds. So that's P equals 8.3 times G for gallons. Okay? Got that?
Yep.
Easy enough? Yep. Now, the next question was, how much does 30 gallons of water weigh? Now that we have the equation, let's find out how much 30 gallons of water weigh. Well, we could do that now because we know how much 1 gallon weighs. So, now our formula says this. P equals 8.3 times 30. So, Tootsie Roll to the first one to find that out for me correctly, without a calculator.
$24.90.
Nope. Decimals off.
249.0.
I'll give both to you. 249. Sorry about that. 249. So 249 pounds is the answer. So when you're doing problems in your book, they're going to look like the ones we just practiced, A, B, and C. Okay? They're going to look just like those. So when you have a question on it on today's lesson, if you have a question on it, you can go back to what we just did and look that up first. Okay? Or not. Wow. This is the video that never ends, apparently.